Well, all right. Welcome back. Today, we're going to be going over section 5.5. And as you know, there are PowerPoint slides associated with this section. However, I'm just going to put the information here on the light board, and so we won't need to have reference to those. However, and we'll see this in just a couple minutes, I will be getting to today using this guidelines sheet or indirect truth tables handout that I've also posted on the website. So before you go any further, you're going to want to get, at least in front of you electronically or if not printed, the indirect truth tables guideline sheet that's been posted with this section. At any rate, though, before we get into that too much, let me just kind of take us back to where we were before section 5.5. And so just to remind you that in section 5.4, what we were learning about there is the ordinary truth tables method for determining whether or not an argument is valid or invalid. Now what we see here on the screen is an argument, and we'll see if it's valid or invalid, but we have one premise, two premise, and then the conclusion over here. And so you'll remember then from 5.4 that the way we would set this up in terms of using an ordinary truth table is over here off to the left. We would list all of the different letters that are in these various statements, right? So we begin by getting B, A, E, F, G, and H, right? We'd list them all there, and then we go about making a table. And of course, what we'd note here, somewhat alarmingly, I suppose, is that for an argument like this with 6 different letters, we're actually going to have 2 to the 6th number of rows, which, technically speaking, is 64 rows of a truth table. Now, I've assigned this problem for many years, and in the decades that I've been teaching this class, I've only ever had 2 students go ahead and do the 64-row truth table to determine if this is valid or invalid. You were certainly free to do that, and of course, it is a good work in terms of, familiarizing you with the truth tables, of course, and the whole process of doing an ordinary truth table. However, I'm hoping that today will bring good news. And the good news is that we don't have to do a 64-row truth table here to determine if this is valid or invalid, thanks to the technique of indirect truth tables. So I will just remind you that when it comes to the exam on this material, when I ask you to do an ordinary truth table, you will need to supply the pool of values, right, and line it up that way to show that an argument, for example, is valid or invalid or whatever I'm asking you to do with that. I will also remind you, though, that when it comes to the exam, I won't ask you to go beyond an 8-row truth table. So don't worry, don't lose any sleep over there being a 64-row truth table on the exam. So having said all of that, we can sort of wipe the sweat off our brow and not have to worry about doing an ordinary truth table to determine if this argument is valid or invalid. What we're going to do instead is we're going to use what's called indirect truth tables to make that same determination. And so you might want to pause, but I'm going to draw your attention to the indirect truth tables handout, which I have here on my iPad, and I'll just talk to you about this technique. So as always in this class, I like to go through the procedure first, show you the steps for each of these things, and then after we've gone over the procedure, then to talk to you about why this process works, okay? So you'll note here that the first step of this process is to make the conclusion false underneath its main operator. And so we go to the conclusion here, we make it false, and I'm not only going to make it false, I'm going to make it false in a circle there. I'm going to go ahead and erase this so it's not so distracting. Right, and that circle there is simply representing that is the main operator for this conclusion. Now, we're not quite done here, all right, because not only have we made the main operator false, we now need to kind of work backward and figure out, well, what would it take to make that wedge false? And of course, we hopefully will remember that the only way to make a wedge false is to make both, in this case, the F and the H false, and so we fill that in. All right? So this is what I mean by step 1, making the conclusion false. You put false in a circle under the main operator, and then work out what that would take in terms of the other components of that statement to make that false. Then we go to step 2 in the procedure, and of course the second step there is to plug those values into the other premises here. So in other words, where we see that we find an F, we'll put false underneath that, and where we find any H's, well, we don't find any H's, so we don't have to plug anything else in there. And so we've accomplished step 2. Just take this information and plug it in to the premises where we find those. Step 3 is to make the premises all true underneath their main operators. So we put a T in a circle, in this case under the dot. In this case, we put a T in a circle under the triple bar, right? Because those are the respective main operators for those two premises. Now, when I say make, and I put that word in quotes in the guidelines here, the handout, I mean that our goal is to make them all true. That's what we're going to try and do, try and make them all true. We might not be successful in that, and we'll think about what that means if we are unsuccessful. So that was step 3. Step 4 says, and this is the most difficult step in this process, step 4 says to start with the easiest premise to work on. Now, I haven't defined here in the sheet what the easiest amounts to, or how we would determine what the easiest premise to work on would be. So I'll just explain it here very quickly. The easiest premise to work on will either be the shortest premise, right, simplest we might say, and certainly this is simpler than this one, or it could be determined by the information we get from the conclusion. So we did turn up one element here of this first premise, but I will just tell you that since this is a shorter premise, I'm actually going to start here, even though we did turn up information here. Now, if I had turned up a bunch of information across here from the premises, I would be more inclined to start with that premise. But again, that's not the case. So at any rate, let's start with this premise and try and make it true. And so what we're doing here is we're asking ourselves, well, it's a dot as the main operator, so how many ways are there to make a dot true? And again, here the good news is that there is just one way to make a dot true, and that's to make A true. And we have to be careful here. We want to make the tilde true, right? The tilde will be feeding into the dot from the left and the A from the right. That will make, in turn, the G false, right? So the G is going to be false. So we get true dot true, making that true. Now, we're going to take, as it says here in the instructions, take that information, plug it in where we find it here. So we have A is true, and we have G is false, but we don't have a G, so we're done with that. Step 6, it says we're going to continue now until we're able to make all the premises true. So we're going to go to this last premise in this case and work on this to try and make it true as well. So while we're doing this, we of course want to be thinking about the order of operations. And so hopefully we can recognize that it will be the dot that's going to feed in to the triple bar from the left, and then the F value feeding in from the right. So if we've got false feeding in from the right, we want to make the triple bar true. That can tell us right away that the dot has to be false, right? False, triple bar, false will get us true. If this had turned out to be true here, it wouldn't work. We wouldn't be able to get true there for the premise. So we need to see if we can get the dot to be false by plugging this stuff in. Having said that, look at this. A is true. The true is feeding into the horseshoe here, right? Now we can know that in fact, well, we can at least put it this way. We can think about what if B were true? What would the horseshoe be, right? We'd be looking at true, horseshoe, true, and of course that would be true. But what if B were false, right? That's the other possibility here. Then we'd be looking at false, horseshoe, true. And false, horseshoe, true is, you know what? It's still true. So actually we know the horseshoe is true. It doesn't matter what B is. And so I want to draw your attention to this note at the very bottom of the sheet. The note says when it doesn't matter what a particular letter's value will be, right, when it could be either way and doesn't affect the truth value of the statement, leave it blank, right? Leave it alone. Don't plug in true here because you like truth or false here because you like to lie. Just leave it blank, or if you want to, you can indicate it with a T/F. So we know the horseshoe's true. That, of course, will be feeding into the dot along with the E here. So we're looking at true dot something that needs to make the dot false. Well, if we've got true feeding in from the left, then that E has to be false to make the dot false. Now we're looking at false, triple bar false, which is true, so we've worked that out. Well, what does that mean? Well, going on, we just completed step 6. We continued to be able to make all the premises true, or we got a contradiction, but we were able to do it. Step 7, if there was more than one way to make the conclusion false, well, there wasn't more than one way to do this, so we can ignore that. Step 8 then, if you were finally unable to get all true premises in a false conclusion. Well, we weren't unable to do it. We were able to get all true premises in a false conclusion. So what do we see here in step 8? Well, if at any point in working on the problem you're able to get all true premises with a false conclusion, you have shown that this argument is in fact invalid. Right? So remember, anytime we have an argument that allows for all true premises in a false conclusion, that argument is necessarily invalid. It has to be invalid. So just to relate this back to ordinary truth tables, if we did a 64-row truth table, what we would find is that on actually 2 rows, right? One row would be where B is true and A is true, and E, F, G, and H are all false. And then on another row where B is false, A is true, and the rest of these are false, right? Just taking these values from what we've determined over here. On 2 rows in that huge 64-row ordinary truth table, we would find all true premises and a false conclusion, which we learned in 5.4 always indicates that it's an invalid argument, right? Because a valid argument would never let this happen, and clearly it can happen with regard to this argument. So what we're looking at here is really the ultimate shortcut method, right? We've gone straight to the heart of the issue here. When we make the conclusion false, is it possible for the premises to be true? And the indirect truth table method shows that, in fact, it is possible.